Thank you for watching this video demonstration on frequency tables. In this video, we're going to focus on creating frequency tables and corresponding graphs using Jamovi. This data set that we're using is a combination of nominal data as well as continuous data, which is great. Then we can create different frequency tables and talk a little bit about how we interpret those. So where do we start? First, we need to go into Exploration. That's our menu. And then we select descriptives from that drop down. Again, once we have selected what we want to do, we need to tell Jamovi what we want, what data do we want descriptives on. So let's move our place of residence. We know that this is nominal scaled because the icon is those three intersecting circles. And we're going to move those into the variable box. Because this is strictly categorical, all it's going to give you is the number of responses in that column. It's not going to give us a mean, a median, standard deviation, min and max, because it's not numerical, so we wouldn't expect to see that. What we're going to check is this little box here, and we see that right next to the frequency tables checkbox is two icons. This is indicating that our data needs to be either nominal or ordinal in order for us to create a frequency table. In this case, it's nominal, so that's good. We can just check the box. What we see here is we have two categories. And this is place of residence, so Northern California and Southern California. We see 27 participants said that they live in Northern California, and 23 participants said that they lived in Southern California. So 54% of our participants said Northern California and 46 said Southern California. In terms of the cumulative percent, since we have two categories, it's not really interpretable. They are just a running total of the contribution, which makes sense. 54% are Northern California, and then 100% are either Southern California or Northern California residents, I should say. Okay, so now that we have our frequency table, let's create a corresponding bar graph. So if I click on plots, they call it bar plot in Jamovi. I'm just going to click that box. And now we can see visually the pattern. So we know that there are more people that said that they lived in Northern California in comparison to Southern California. But sometimes the visual of a graph can really show us the pattern, especially when we have more categories. That can be really helpful. So on the x-axis, we have our place of residence, and then the y-axis is our frequency, or what Jamovi calls counts. The height of the bar indicates the frequency, so we can interpret this that there are more people that said that they live in Northern California than Southern California, and that makes sense because of the values that we saw in the table. So that's one example. Let's go back to our data here. We're going to use the next categorical variable, which is it is political group affiliation. Democrats is one of them. This has three groups in the column, Democrat, Independent, and Republican. So let's go back to our analyses. We're going to go to descriptives again, and we're going to move political group into the box. We're going to check frequency tables. And now we see that there are three groups, Democrat, Republican, and Independent. Now, the way that Jamovi sort of organizes nominal scaled variables, or these groups, is it's really putting them in order of when they appeared in the data set. So the first category that appeared was Democrat, the second was Republican, and the third is independent. And that makes sense because we know that with nominal scaled variables, there's no inherent order. However, we could change the order, which I'll show you in just a few moments. But to interpret this, we see that we have our three categories. Here's our frequency, or what Jamovi calls counts. Here's our percent to total. So we understand that 50% of our participants identified as Democrats, 36 identified as Republicans, and 14 identified as independent. In terms of the cumulative percent, if we look at this, we say 50% are Democrat. We understand that 86% of our participants either said that they were Republican or Democrat. I don't know where we would use that, but maybe we might want to summarize that in some way in our reporting of our results. But this is our frequency table for our political group. Before we move the categories, let's create our bar plot so we can show the pattern of the results. So we can see Democrat, Republican, and Independent. It kind of makes this nice slope. And again, these are just arbitrarily put in this order based on the response. I shouldn't say arbitrary. It's put in order of when they occurred in the data set. So Democrat was first, then Republican, and then Independent. So if I want to change the order of how these appear in the table as well as the graph, I need to go back to data. So I'm going to click on this tab and open up the data. I'm going to go to the political group column header. I'm going to double click on that. That opens up the data variable field. You see these levels here? What I can do is I can highlight Republican and I can arrow it down. So now the order is Democrat, Independent, and Republican. It's in alphabetical order. I can close up, and now we see that reflected in the table. So we see it Democrat, Independent, and Republican, and then we also see it as on the x-axis. So we can change it in any order that we want. We just chose to put it in alphabetical order, but again, it's really dependent on what we want to reflect. The last thing I'm going to do is just do a frequency table for age. So we know that age has to be either a nominal or an ordinal variable. So we're going to go back to our data. I'm going to double click on that, and I'm going to change this to just nominal, just so that I can create a frequency table. I'm going to close up our data variable field. I'll go back to our descriptive analysis. I'm going to move age into the box, and I'm going to create a frequency table. So this gives us the frequency of each age that appears in our data set from lowest to highest, the frequency, each age contribution to the total. So if I was looking at 25 years old, we had 3 participants who said that they were 25. That's 6% of our participants. I could also use this last column to say that 54% of our participants were 25 and younger. So it really makes a lot more sense to interpret that cumulative percent in terms of numerical data, because it makes more sense. That's kind of how we think about numerical data, especially with age. It really is a good analysis here. And then for this data, we would want to do a histogram. This gives us it's not a beautiful graphical. I know other statistical programs probably give us a better representation of the data, but we can see the pattern of the data emerge. So we can see there are heights. I wouldn't call this necessarily perfectly normally shaped, but it does take on a roughly normal shape where we see some tapering off at the ends and some height in the center, although there are some that are not reflected in this data set as much as some of the others. But this gives us an idea of the overall pattern of the data. Can be impactful for our readers if this table becomes kind of a little bit unwieldy with all of the ages. So that's our frequency table for qualitative and quantitative data, as well as corresponding graphs.